Hi, welcome to today's lecture in our software engineering series. In this session, we will dive into software testing strategies. Together, we will cover key topics in the following order: level of testing, box testing, manual versus automated testing, comparison table. Let's get started. Introduction. Software testing is not just about finding defects, it is about ensuring the product meets the standards expected by users and stakeholders. Early defect detection can save significant time and memory. Fixing a bug during development costs much less than addressing it after release. Testing ensures that the software is robust and ensure delivering consistent performance under different conditions. Testing strategies overview. Black box testing, testing without internal knowledge of the system. This strategy focuses on the system's output and user interaction, ignoring the internal code of our structure. White box testing, testing with knowledge of the internal logic code. This approach requires a deep understanding of the software's code base to validate its logic and workflow. Gray box testing, a combination of both approaches. Combining the strength of black and white box testing, this method is ideal for testing integration or APIs. Black box testing focus on functionality from the end user's perspective. Black box testing examines how well the application meets user expectation without looking at the code. Tester role, ignorant of the internal code structure, the tester acts as an end user, focusing on input and expected output without understanding how the system works internally. Methods, equivalence partitioning. This divides input into valid and invalid groups, reducing the number of test cases while maintaining coverage. Boundaries value analysis. Test case focus on H values at the boundaries of input range, where errors often occurs. Decision table testing. Decision tables provide a structured way to identify and test various combinations of input and actions. White box testing focus on internal logic and code structure. White box testing ensure the system is internal process work as intended and efficiently work scenarios. Tester role require knowledge of the system's internal. This approach demands coding knowledge to understand and navigate the logic behind the software. Techniques, statement coverage. Ensure all line of code is executed at least one. These techniques verify that no part of this code is left untested, ensuring basic functionality. Branch coverage. Validate all possible branches in decision points. Focus on ensuring every if and else decision point is tested for all possible outcomes. Path testing. Verify all execution paths. These techniques identify and test every possible path through the code, ensuring no logical gaps. Gray box testing focus on partial knowledge of the internal structure. Testers have some knowledge of the code, but they primarily focus on external behavior to find integration issues. Combines black box and white box testing benefits. This approach leverages the strength of both methods to validate external functionality and internal logic in tandem. Use case testing integrations and complex workflow. Gray box testing is ideal for validating API, system workflow, and interaction between different modules. Level of testing. Unit testing, testing individual components. This is the first level of testing, focusing on isolated modules to ensure they perform as intended. Integration testing, testing interaction between components, ensure that combined modules or system interact and work together correctly. System testing, testing the entire system as a whole. This validates the system against requirements, simulating real-world scenarios to ensure end-to-end functionality. Acceptance testing, ensuring the system meets business requirements. The final step, where stakeholders verify whether the system fulfills business need before deployment. Manual versus automated testing. Manual testing performed by humans involve human observation, making it suitable for exploratory or user experience testing. Suitable for exploratory and ad hoc testing, manual testing is flexible and valuable for scenarios where intuition and adaptability are required. Automated testing, user tools and scripts. Automation involves creating script to handle repetitive tasks, saving time and ensuring consistency. Efficient for regression and repetitive tasks. Ideal for large projects where frequent updates require repeated testing cycles. Automated testing tools. Popular tools are Selenium web testing. Selenium is widely used for automating web application testing across browsers. JUnit unit testing. JUnit is primarily for testing Java application at the unit level. Appium mobile testing. Appium automates mobile app testing across platforms like Android and iOS. Postman API testing. Postman simplifies API testing, allowing testers to validate endpoints and responses. Advantages: scalability. Automation tools can handle large test suites, scaling up as the project grows. Faster execution. Automated units test runs quickly and consistency, enabling faster feedback on code changes. Comparison table. Manual testing is the best when creativity, intuition, or user experience evaluation is required. Automated testing excels for the repetitive task, offering speed and reliability. Choose the method which project is better, complexity, timelines, and budget. Takeaway: effective software testing requires quality and reliability. Testing is a concrete of quality assurance, ensuring the product delivers value to users. Strategies: black box. Each strategy has required strengths. Combining them ensures comprehensive coverage. Approaches: a balanced approach manual leverages and the strength of both manual and automatic testing to create a robust testing strategy. Thank you.